Hello everyone, welcome to Physics Classroom. I am Olatunji, your physics tutor. To our returning viewers, welcome back to your Physics Classroom. To our new viewers, welcome to this classroom. Please do well to press the subscribe button, turn on the notification button, and likewise like and share. Please comment in the comment box, and especially maybe you have a topic you want us to discuss. As we have all know, we are in the season of Neco and we have released a lot of videos on physics, chemistry, biology, practicals. Now this is another episode of Physics Practical here on our channel, Estimator Aditunji Edu Consult. Now, we are bringing out this question from 2017 and we have the diagram on our board. Without wasting time, we will be carrying out the experiments together as we will be reading the question. But we are from the preamble, we said we are all provided with a uniform meter rule. We have our uniform meter rule. We have the knife edge, the mass, six, and other necessary apparatus. They say we should suspend, but we know anytime you are carrying out experiments on equilibrium or principle of moments, the first thing you do is what you determine the center of gravity. Now I will sit down so that we'll be able to enjoy it. I will sit down and place my meter rule, my knife edge, masses. Let's go and catch fun with physics. Alright, we want to start. Let me sit down and let's enjoy it together. Like we have all known, I've told you several times, not all meter rules are 50 centimeter center of gravity. So you need to take your measurements. Checking my measurements. Let's confirm together. If it's balanced, it will not touch something. It will not touch anything. If it's still touching, it's not balanced. It must be free. Touching. Is it touching? It's still touching. When you are doing this type of practical, you don't rush. You don't rush. Wow. Can you see? You can see my surface here is free. That is, it shows it's balanced. Alright, let's start. So I will write my CG now, the center of gravity. Like I said, I want to sit down to enjoy it. You also bring that to book, your pen, and enjoy it. So my CG is 50 centimeter. Now let's go. What's the next thing? They said we should fix a mass. We should fix a mass. We should fix a mass. I want to see. Right, let me suspend my mass. I have the rope. I want to suspend. They say I should suspend. That mass we want to suspend is 20, but it's unknown. They call it unknown for us. I'm starting my reading from here. Starting my reading from here. The mass we are suspending and will be fixed at 15. So I will ensure that this one is always there. And the first measurement said I should place, you can see that the thing is falling. So they say I should place when M is 20. Now let me go by that. This one is a fixed mass. Now the one I want to use right now is a variable mass. So let me now see where this thing will be to balance the point. Until the surface is free, this is 20 fixed. This one is unknown. This one is the normally is 20. I need to continue adjusting until it is free from the floor. Now you can see it's free now. It's free and it's free at 85. Since it's free at 85, note this place is 35. 50 minus 15, that's 35. For this place is fixed, 0.0, and this place 85 minus 50, that's 35. You don't need to waste time On that, we have achieved that. Now let's go to 30. I want to add. This is my 10. Adding it to it, you can see it's falling. So definitely I need to move it towards the center. You can see it's falling here, right? And also be watching my center of gravity. It must not shift from there. I'm going to 30. I'm going to 30, 20 plus 10, 30. I'm going somewhere. Oh my goodness, I think you can see something very meaningful. Surface free. Now it's free. Now let me now see where it is free. I can see this thing as 73.3. 73.3. 73.3 minus 50. That will give us 23.3. 23.3. This place still remains 35.0. Remember, we are going to 60. So 40, 50, 60. Alright, so for 40 now, 20 plus 20 will give us 40. So let me remove the 10 and insert the 20. I hope you are enjoying it. Please take your time to watch. Don't skip anything. It is it's a season of examination. Let's get it right. We are working on the information we receive, and the information is meant for you. So please, you can see I'm also checking my center of gravity that the thing is not moving from it. Still falling down. Now it's about to move to that side. What do you observe? What do you observe? Free from space, right? Free from where? Free right? Free right? Now I can see 67.5. 67.5. I can have 67.5. 67.5 minus 50. 67.5 minus 50. 67.5 minus, that gives us 17.5. So it's still being fixed, 35.0. And let's go to 50 now. I want to increase it. It's falling, right? So we are going to 50, 20, 20, 10. So to balance it, wow, I can feel that it's not falling. So this thing gave balance as 64. 64 minus 50, that's 14. 14.0. Now check on something. I am using 2 decimal number, so I need to maintain it throughout. So that's what I want to do right now. I want to maintain my 2 decimal. So this is 30. I want to maintain my 2 decimal. 50. 50. I want to maintain it perfectly. 5000, and this place still means 35.00. And for 60, now 60, that is 20, 20, 20, 60, and we complete our experiment. I hope you are enjoying it as the thing is going. Now I'm going to 60. Oh my goodness, it didn't want to fall. Still maintain my center of gravity. You can see the way the thing is struggling. Oh my goodness, okay, it's not on the center of gravity, can be taken. Falling again, we get there. Okay, so we are close. We are close. Is it touching? if it's free, until it's free. Once it's free, we are good. Once it is free, we are good. I can still enjoy it a little bit. Now, very free, very free. You can see when I was shaking it, nothing. So I can see this one at 61.7. 61.7, but I know I can't write 61.7. 61.7 minus 50, that is 11.70. This thing wants to maintain 35.00. And that's how I'll finish the experiment. And that's so very simple. Now, they say we should find the L inverse. Now, we can find the inverse of L in centimeter inverse. That is, this is our L. 1 divided. Let me pick up my calculator. Let me pick up my calculator to do that quickly. Yes, I have my calculator with me to pick up, to quickly get the value. 1 divided by 35. What do I have? I'm writing these 3 decimal places now. 0, 0, 2, 9. I move to the next one. 1 divided by 23.3. I have 0.043. Okay, we move. 1 divided by 17.5. I have 0. Hope you are checking the trend. 57 is increasing with the mass. So let's finish it. We have 1 divided by 14. Here I have 0.071, and lastly I have 1 divided by 11.7. So I'm having 0.085. And that's how we finish the whole experiment and the table. So the next thing we are going to do now is graph. Plot our graph. So to plot our graph, graph. What we need there is that we need the title. The title of our graph is already in the graph. The graph of what? Of M on the vertical axis against L inverse in centimeter inverse. That's the title. We'll go for the scale. So the scale. Now to talk about the scale, let's check. On our highest value 60, lowest is 20. So I can go with 2 centimeter to represent 20. 2 centimeter or 2 centimeter to represent 10. That one's okay. On M G axis, 2 centimeter to represent 10 grams. On my L inverse, so on L inverse, centimeter inverse, I will say, okay, with my values, I can still go with 2 centimeter to represent 0.1, 2 centimeter to represent 0.010 centimeter inverse. And with that, I'm good. How will the graph look like when you plot the graph? L will be here, L in G, and L in the inverse. L inverse in the inverse side also will be here. We have something like that. We have something like this, Please, for issue of graph, we have the for the graph. Please do well to watch our videos on graph. I don't want this video to be longer than this. That's the reason why I want to just sketch the graph for us actually. But for the comprehensive graph, please watch our video on graph. All right. So moving forward, now I've written title scale. Since the mass is increasing downward, this one also increasing. So definitely we are going to have positive direct graph. Maybe we have point here as well. M1, M2. When you trace it, M2, M1. Here, L inverse 1, M2, L inverse 1. You know how to do that, and from there you get your slope. Slope is change. The change, that is M2 minus M1 in gram over L2 inverse minus L1 inverse, all in centimeter inverse. And at the end of the day, your answer will be gram cm. This inverse will turn against this division sign, and from there we are going to have G inverse we are going to have G centimeter as our unit for the slope. For the precautions, take 2 precautions. What are those things I experienced? I said I avoided error to parallax when taking measurements on the meter rule. I also ensured that my center of gravity is fixed, my mass is fixed, there are no mass fixed, and likewise I avoided my environment from from air blowing, so that it won't affect my balance or my meter rule. So this is the end of the video for this episode of mechanics that we call principle of moment or equilibrium. So I will be expecting you in the next video. Bye for now.